Welcome to my full stack web development explainer video. This is going to be a visual tour of the full stack, covering these technologies noted here, essentially everything in the course so far before React. So my plan for this video is initially to do a kind of high-level overview and basically explain how each element connects to each other, which will give and sort of the technical aspects, which will give some context to the next section, which is a nice sort of analogy of a person working in a cafe, and how each element, each one of these languages or frameworks corresponds to a certain element, and how they interact. Then we'll do a deep dive into a very important topic, async await, that I think is fundamental to understanding web development, especially coming from synchronous languages. And then finally, we'll do a quick live coding demo of that very feature and kind of put all of them together on a small scale. So first of all, here is just a simple mind map or concept map. At the top, we have the browser layer, and then the server layer and the database. So the browser is essentially everything the user actually sees and touches. It has four main technologies. HTML5 is the skeleton. It kind of defines what exists on the page, how the elements relate to each other. And the key idea from HTML5 is semantic elements. We'll get into that a little bit later, but essentially it means that tags carry meaning, not just structure. So each element kind of knows what it is. This matters for accessibility, search engine optimization, and maintainability. CSS kind of defines how everything looks, really. It's the skin, the appearance. It handles everything visual, really. And so you can have exactly the same underlying HTML, but different layouts with CSS. And then Bootstrap kind of builds on that. It's a pre-built CSS framework that speeds things up, really, because CSS can be quite tedious to write bit by bit, especially if you're building custom features like a nav bar and things like that. And so you can have these and buttons and a grid system out of the box. JavaScript is the behavior layer. And so it's sort of akin to the back end. It can do some front end stuff as well, but essentially it listens for events. It manipulates the document object model, which kind of displays everything on the page, and then it also can fetch data from the server. And in order to do that, it uses HTTP requests and JSON responses. So this is the critical connection between the browser and the server. They don't share memory, they're completely separate, and they talk to each other over HTTP. So the browser will send a request, give me X data, and the server sends back a response, usually as a JSON, which is just a structured text format, or a sort of easily intelligible structured data format. And then both sides can kind of, so then the server can respond with that, and then both sides kind of can read JSON, and essentially this will display what's shown on the web page. So every dynamic thing you see will come through that channel. The server layer is in the middle. This is where the business logic lives. So deciding what data to send, who's allowed to see what, form submissions, and so on. Node.JS is JavaScript running on the server. So it's the same language as the browser, but a different environment. It uses a non-blocking event loop, which means that if it's waiting for a database call or a file read, it's not going to freeze. It will keep running. And then NPM is the package manager, which is kind of how you manage libraries and dependencies. Express sits on top of Node. It gives you routing and middleware. Routing is just matching a URL and HTTP method to a handler function. And middleware is code that runs before your handler. So things like authentication, logging, body parsing. This is where your API endpoints live. Forms are how users send data to the server. So you have get for submitting, get for fetching, post for submitting. And then the web architecture is sort of the big picture question. So how is the app structured? Is it server rendered? Does it use REST APIs? Is it a single page app, and so on? So this kind of ties everything together. And then finally, you've got the database layer. So MongoDB is what we're using in this course. It's unlike traditional SQL databases, which use tables and rows. MongoDB stores documents. So they're JSON objects, similar to kind of JSON objects with flexible nested, and they're schema optional. Documents live inside collections, which are essentially similar to tables. And then Mongoose is the object document mapper, and so that gives the schemas, the validation, and methods like find, save, and delete. And so Mongoose is actually how the server communicates with the MongoDB. So that's the whole stack. Pretty kind of high-level overview of how they all interact with each other. And everything we've studied so far up to this point lives somewhere in that flow. So next, now that we've kind of looked at the full stack, I want to bring it to life in a kind of way that I like to understand the different elements. And so, you can look at boxes and arrows and kind of try to understand how these things work, but actually understanding it, I'm going to explain this through a person who lives and works in a way that will mirror how a web page works, and kind of map each corresponding element to, an aspect of that person, shall we say. So hopefully this helps, because it definitely helped my comprehension. But first up, this is HTML. It's the skeleton. It defines what exists on the page and how the pieces relate to each other. What's at the top, what's in the middle, and what's at the bottom. If you remove the skeleton, it's just a pile of bones and it collapses. So before HTML5, websites were essentially a combination of divs and spans. And so devs would write div class equals, and then that's how they distinguish between things. So they'll have header, they'll have footer, they'll have body, so on. And okay, as a developer, you come in, you read that, you can tell what it is, but that doesn't know what it is. The browser just saw generic boxes because there was no meaning to any of it. It was just a label, essentially. So HTML5 changed this by introducing semantic elements. And so now, for example, with the skeleton, you'd have the skull as the header. And what it is, it knows what it is, everyone's happy. Next, you would have maybe the rib cage, or the sort of main middle areas as main, and so the rib cage knows that it's a rib cage, and again you've got a footer here. And so it really helps both for search engine optimization, rather, where you can have different headers. So we kind of looked into that earlier in class, H1 to H6, and you can kind of structure them in a way that search engines know what to kind of display from your website and how to appear higher in search engines. But then you also have, main as the main body of text, and footer, and they will kind of appear at those. It gives it a bit more structure inherently without any CSS involved. So you can have a large header at the top, you can have the main body of text, and you can have, a footer at the bottom. And so it helps both from the sort of computer side and from the developer side who comes to read the code. Then along comes CSS. And so CSS is essentially everything you can see. So the skin, the hair, the clothes, it's purely about appearance, how things look, where they are, what color they are, how big they are. And at the end of the day, this might be, the style sheet, which kind of determines, how each element appears. How does the header appear? What sort of color it is. Does it have any sort of, shadow or anything like that? You could have maybe a 5 o'clock shadow here, something like that. And so you can have the beauty of CSS is that you can have a completely different, completely the same HTML, but you can have light mode and dark mode. You can have, and this might be dark mode, and it's got exactly the same underlying person. You can see they look the same, they're the same size and everything. It's just a different shade and different experience for the end user. And you could have, mobile layout might be, a smaller outfit for a specific, occasion. Maybe you can say they're, in workout gear temporarily, but it's still the same person underneath. And so, yeah, any underlying content is identical. It's just CSS handles how it appears. Yeah. Next, JavaScript. I like to think of JavaScript as the sort of nervous system or the muscles. So this is supposed to represent, it's going to listen, react, and make decisions. Otherwise, the page would just be a static document. And so this is supposed to represent someone, tapping them on the shoulder, for example. This might be a click event. And so obviously you see the click, and JavaScript will determine how to deal with it. Again, another example might be something like mouse over, might be someone walking nearby. And that is essentially, they're close enough that you notice them, you have a different reaction, but you're not kind of changing your whole behavior. You might just, look up and kind of acknowledge them. So similar to, say, a button changing color when you hover over it, that sort of thing. And then fetch, this is how JavaScript talks to the server. That could be, something like waiting for a text, sending a text rather, and waiting for a reply. So you're not just going to sit there and stare at your phone. You're going to go and do some other things, and then when the reply comes in, you can, if it's an urgent text, you can deal with it. And that is the asynchronous. That's the async model. It's non-blocking, and the page stays responsive while the request is in flight. And we're going to deal with that later in the deep dive in the coding demo. So I suppose up to this point, it's kind of been the full browser. So you can think of the person as the browser, the HTML, the CSS, and the JavaScript. HTML has the structure, CSS has the appearance, and JavaScript is the behavior. They're all running on the client side in the user's browser. Then we get to Node and Express, and that is the café. And so I like to think of it as, the person has a job, they work at a cafe. When a customer walks in and orders something, that might be an HTTP request. And the person's job is to take the order and figure out what's needed and go get it. And so Node.js is what makes it possible to run JavaScript on the server at all. It's sort of the environment, the building, the job. And Express is more like the training they receive, so how they deal with those orders. Greet the customer, match their order to the menu. Maybe they want a free JSON, and route it to the right place, fetch the item, so on. This is routing, middleware, request, response. That's all Express is. It's just a structured way of handling what comes in and deciding what goes out. And I suppose tying into that as well, another part of the job would be going and collecting the response. And so this is MongoDB, the sort of storeroom, the pantry. You've got shelves of labeled containers. These would be collections. And then inside the collections, so each of these is a these are all collections, and then inside you might find, a very specific document that you're looking for, a certain type of coffee, or, so maybe a customer wanted some extra sugar, something like that. And so it's essentially, each of the ingredients in the containers are the documents. So when a customer orders something, the person comes back here using their training, the Node.JS Express. They pull the right container, bring it back to the counter, and then when something new arrives, a new user turns up at the coffee shop, or you have a new order that comes in, they label it and put it on the right shelf. They don't really care. It's very similar to an actual pantry. They don't really care about presentation. It's not exposed to the customers, just like it's not exposed to the end user in a web page. So, they're not concerned about presentation. It's just making sure that you get the right thing on the right request. And finally, it's one thing that I suppose has been sort of implied, but I'd just like to make it a bit more concrete. The customer in this fictional scenario is the actual human that's using the web page. So me or you, and so tapping on buttons, or tapping the server on the shoulder. You probably wouldn't want to do that. It's a little rude, but asking, trying to hail them, get their attention. That would be a click event. Typing into a search box might be filling out a form, something like that. And so you can think of it kind of as like a web page, kind of like a cafe where you're ordering things and it's giving them back to you, and there's all this stuff going on behind the scenes that you don't see, but what you do see is sort of the skeleton, the person, and I suppose the cafe as well to an extent, and the appearance of them. And so there's the full picture. That's kind of how I like to understand it. For this next section, now that we've kind of got an overview of what each of the elements are, we're going to do a bit of a deeper dive into JavaScript async. This is the concept that I want to focus on because it's the one that trips people up most when coming from synchronous languages like Python or Java. And it's very integral to web development. Once you understand it, it's, at least for me, it started kind of clicking everything into place. So we're going to cover why it exists, why async await exists, how it evolves from callbacks to promises, and how async await kind of cleans it all up. So I'll keep things moving. Think about kind of loading a web page. It needs to fetch data from the database. If JavaScript just sat there waiting for the database to reply, the entire browser would freeze. You couldn't click anything or scroll or nothing. That's the problem that async solves. It lets JavaScript start some work, move on, and come back to it when it's ready. The key thing to understand is that JavaScript is single-threaded and it can only do one thing at a time, but async lets it manage that one thread really efficiently by not wasting it on waiting. So the original solution were these things called callbacks. The idea is essentially that instead of waiting for the result, you pass a function, a callback, and the system calls it when the work is done. Node.js established a convention where the first argument is always the error. If it's null, everything's fine, otherwise handle it. The problem you can see here is that every new async step has to live inside the previous one. Adding more steps means more indenting. Error handling repeats every single level. And so this is actually what's called callback hell, or the pyramid of doom. It works, but it's really hard to read and almost impossible to refactor. And so along came promises, which fixed this. So promises were introduced in ES6, and it changed how async code was written. So a promise represents a value that doesn't exist yet. It's pending. And will eventually either fulfill with a value or reject with an error. The big win is chaining. So instead of nesting callbacks inside each other, you chain dot then calls, and then they stay flat no matter how many steps you have. One dot catch at the end will handle the errors from any step in the chain. And the other huge benefit is promise.all. If you have 3 independent requests that don't depend on each other, you can fire them all at once and wait for all 3 to finish. So it's massively faster than doing them one after the other, and it makes you able to do them in parallel. Here's the same 3-step async operation written both ways side by side. So on the left you have the callbacks. Each step is indented inside the previous one. Error handling repeats 3 times, whereas on the right you have promises, which is completely flat, and one dot catch handles everything. The promise version is not only shorter, but it's also easier to reason about. You can read it top to bottom like a story and get the user, their posts, get the user, then get their posts, then get the comments, and then render. And that's kind of the mental model you want to think about when programming these things. And then async await was introduced in ES 2017, and it's the most common way to write async code today. The async keyword before a function means it always returns a promise. The await keyword inside it says pause here and wait for this promise to resolve before moving on. But crucially, only this function pauses. The rest of your program keeps running. And so it kind of reads almost exactly like synchronous code, really, is how I kind of interpret it. You're not chaining dot then calls, but you just write step by step, top to bottom, like you normally would, and you handle errors with a regular try catch, which is the same pattern you'd use for any synchronous errors. Under the hood, it's all still promises, but the async await is just nicer syntax on top, really. The most common mistake with async await, because it reads like synchronous code, it's easy to accidentally make things sequential when they don't need to be. So in the top example, fetch users, fetch products, and fetch orders each take a second, but they don't need each other's results. They're completely independent. But awaiting them one by one means they run one after the other. So it's 3 seconds in total. But in the bottom example, sorry, it's come a little bit off the screen here. But you can see that you wrap all of them in a promise.all and await that. So all 3 requests fire at the same time, and we wait for them to finish, which is 1 second total. So the simple rule, the way to think about this is if results are independent, use promise.all, but only await sequentially when one result feeds the next. So to summarize, JavaScript has evolved through 3 eras of async. Callbacks came first. They work but lead to deeply nested, hard to read code. Promises flatten that out and make it chainable, one error handler, and promise.all for parallel work. And then async await is the kind of modern paradigm, which made it all read like synchronous code. And that's the standard way that developers work these days. Key thing to remember is that async await isn't a different system. It still uses promises. It's just cleaner syntax on top. And yeah, again, the key rule, use promise.all for independent requests. Await sequentially only when one result feeds the next. So for the live coding demo, I want to take you through a brief example of everything we've learned so far, actually working together. So HTML, CSS, JavaScript, async await, and the fetch API. So we're going to build a page that pulls a list of users from an API and displays them on the screen. So I'm starting from a completely blank file, index.html and app.js. That's all we need here. This is the API, and then I've got a live server running with the index.html just to show the updates. So initially we'll start with HTML5, just a generic template. So this just gives you, a good, nice, easy document that's pretty standard. You can customize it if you want. We're going to leave it pretty similar. And then here, what I'm going to do, just in the interests of time, is I'm going to do this is just a CSS sort of equivalent. Typically, you'd write CSS in a separate file, but just to make it readable and, give a bit of an example of what CSS can do, I'm just going to write some quick styling. So in this scenario, this is just formatting the body of text and the list that we're going to do to pull the users, just giving it some very basic sort of padding and coloring and size and all that fun stuff. So here we're just going to write users. We're going to do an unordered list. Going to give it a ID list. We're going to just write for now loading, and then right at the bottom here, just so that the page is rendered before we run the script, we're going to do app.js. And so right now, if I have done this right, there we go. We've just got users loading, very standard boilerplate HTML. So what I'm going to try to do in this is I'm going to try to teach what happens if we try to do this synchronously first. So here what I'm going to do, synchronous example. We're going to do const res equals fetch, so just using the fetch. We're going to actually pull this from here, and then we're going to do console.log res. And this is actually an important note that we learned in class, is that you should always have the console open when you're working on a website. So we're going to go here rather, inspect, and you will see that because we've tried to fetch it like a normal synchronous function call, we get a promise back, not the actual data. So you can see the promise is fulfilled, it worked, but it's not actually rendered on the page. And so we need to tell it to wait properly, and that's what async await is for. So what we're going to do now, I'm going to comment all this out, and we're going to make an asynchronous function called load users. And then we're going to do const res, same as before, except we're going to do await fetch this, and then we're going to do const users equals await res.json, because res.json, which is just JSONifying the results, is actually also asynchronous. And then we're going to console.log users, and we're going to do a little load users call here just so it knows to call it. And now, because we've wrapped it in an async await function, you can see that the users are here. However, obviously we don't want them to just be logged to the console, we want them to show to the actual users. And so what we're going to do here is we're going to go const list equals document dot query selector list, and we're going to do list init HTML equals users dot map. So this is grabbing the unordered list. Let me write it out first, and then I can explain what it's doing. One second. Just going to join them, join the string, and there, voila, it's now displaying. So you can see this is pulling this from here. So you got Leanne Graham and sincere@april.biz, and so what it's doing is it's essentially selecting the list, and then it's mapping it to this string. So you're taking the list, you're doing the name -- email, as you can see here, and these are taken from the JSON, so name, email, and then it's just joining them into a string, which can be into one HTML string and dropping it into the list. And so that is more or less it. One good practice is to wrap the entire thing in in fact, I'd say it's a very important practice actually, is to wrap the entire thing in a try-catch error handler, just so that, actually, just in the interest of time, I'm going to just copy this. So that if there is an error, in this case there isn't, if the network is down, it might not even be on your side. If the network is down or the API returns an error, you can show a friendly message to the instead of some sort of broken page and not understanding what's going on. So yeah, that's the full file. You got the index.html with the you've got the HTML skeleton, some very simple CSS, just put in the style in sheet. Obviously, usually you'd use a separate style sheet. You've got the script, the JavaScript down here, and then you've got async await and yeah, a fetch call, and that's pretty much it.